Thanks for coming. This is not labor, this is not I/O, and this is not game theory. It'll be okay though, don't be scared. What I thought I would do when I was asked to participate in this was maybe show you guys a little bit about how a lot of the stuff you guys have been learning about, nested fixed points, indirect inference, simulated method of moments, how that kind of shows up in something that looks maybe more like what people might call macroeconomics. I'm going to write down an aggregate model. I'm going to have lots of heterogeneous firms doing things, but I don't just care about what those firms are doing. I care about what it looks like when I add them all up, right? So I don't like to use words like macro and micro because I don't think in 2024 they're very useful. But I am just sort of thinking ahead. I'm interested in aggregating all these things up and thinking about some sort of big quantities and about utility. And so that's kind of what I thought I would talk about today. So the application I'm going to look at is thinking about international trade. So among other things, I study international trade. And these are the kinds of questions that people think about in this field, right? So that the first set of questions, thinking about the actual firms themselves and their dynamics. One of the sort of striking properties of economies across the world is that not that many firms are engaged in international trade. Most firms just sell locally, right? And so why is that, right? What are the costs that keep firms from trading and that keep us as consumers from kind of reaping those gains from trade, of having more varieties and cheaper varieties? So trying to understand the entry and exit of firms into foreign markets and the kind of life cycle. And I'll show you a little bit of data on that as we get going, right? And that often tells us things about technologies, trade barriers, learning, uncertainty, lots of interesting questions here and data to kind of answer them. And then the second set of questions are those kind of aggregate outcomes that I talked about, right? What are the aggregate effects of all of these things happening, all of this churning of firms in and out of markets, their growth, their death, the effects of trade policy, right? So what I'm going to then show you at the end today is what do we get by modeling? I mean, it's going to take a lot of extra work. One of the things I think that we've seen throughout this whole conference and workshop is that this stuff is hard. It requires, really kind of beating up your computers and yourself to try to get this stuff to work. What do we get out of it when we look at aggregates? And so, how do the gains from trade matter when we kind of think carefully and try to get right what goes on at the firm level? How do these things help us understand the dynamics of the aggregate economy, how the business cycle evolves, what happens to things like real exchange rates and their response to shocks, right? So at the end, I'm going to show you that you get some pretty different looking aggregate dynamics out of a model when you abstract from the things that are happening kind of at the firm level, right? So you could kind of think, I guess, of those first set of questions as being kind of micro questions, the kind of questions an I/O economist might answer. And then the second set of questions, something more about aggregates. So that's kind of some of the things I want to talk about today. The modeling approach, this is going to be at the firm level a dynamic, discrete entry choice model. I'm a firm. I face some sunk costs of entering. So I've got a forward-looking decision problem I'm solving. There's uncertainty, maybe idiosyncratic, maybe aggregate. Those are the kinds of models you guys learned a lot about on the first day of this. But then I'm going to take that dynamic discrete choice model and I'm going to embed it in a two-country general equilibrium model. Right? So now I've got firms in two countries. They're trading. Some of them are trading. And I can start answering kind of questions about the aggregate. Now that's going to be kind of more difficult. And so I'm going to make some simplifying assumptions in certain places to try to give me tractability. And part of what I kind of wanted to do today also was try to talk a bit about why we make the choices that we make. Right? I remember when I was a grad student, just thinking that there was just always one right way to do things. And a lot of times there's different ways to do things, and I try to give you some sense of what I was thinking about when I made some of these choices. Sometimes I wasn't thinking, but when I was thinking, I'll tell you what I was thinking. So the nice thing about this approach is that when you're building everything up from kind of firm decision problems, you can use the firm level data to discipline the model, right? So the aggregates of my model are driven by the sort of micro behavior of these firms, and I can discipline that kind of using firm level data. So that's going to be stuff like indirect inference and SMM. So these are kind of applications of that, and then I'm going to aggregate this stuff up. Okay, so here's what I'm going to do. I'm going to very briefly just sort of talk a bit about the data to give you a sense of what this stuff looks like what are the big patterns that people see. and with a focus on entry, exit, and growth. Then I'll lay out in partial equilibrium, I'll just lay out like the dynamic discrete choice problem, and then show you how to put it into general equilibrium. Then I'll spend some time talking about how you compute this thing and some problems and some difficulties in the estimation. And then, as I mentioned at the end, I'll show you kind of what trade liberalization looks like in models with all of this interesting firm dynamics in it, and in a model where firms are just sort of static and making kind of simpler discussions. And we'll see that it's sort of very different, right? And so kind of going and trying to get the micro part right kind of it's going to make a big difference. Okay, so let me just chat a little bit about data for a moment. So imagine you're in the United States, you've got a whole bunch of firms. Some of those firms export, some of them don't. Some of them export a lot, some of them export a little. I'm going to use words like extensive margin, right? That's like the 0-1. That's like the discrete choice part. Do I export anything or not, right? And so for lots of firms in the United States, the number is 0. They don't export at all, right? And so we think about the extensive margin. We often talk about the export participation rate. What fraction of firms in an economy actually engage in international trade, okay? The intensive margin just says conditional on exporting, how much do I export, right? So I'm going to measure this as just the export to sales ratio. And so how much of my total sales are made abroad, right? Okay, let me just show you a couple pieces of data. So here's a way to kind of decompose the aggregates. So on the left-hand side, this is total exports divided by total sales. So in the United States, that's, I don't know, something like 13%, right? So of all the sales that takes place in kind of tradable goods, manufacturing, agriculture, stuff like that, it's about 13%. Where does that come from, right? Where are the sources of sort of change, of growth of something like this? Well, suppose I have data on firms, which I do, and let's just order these firms so that firms 1 through small n are exporters, and then the rest of them are not, right? So the first term on this right-hand side here, that's just the export participation rate, the number of exporting firms divided by all the firms in the economy, right? That's the extensive margin. So you think about how does when I see that the aggregate amount of exports have grown in an economy, did it grow because there are more people who are exporting? That's that first term. Did it grow because here's that export sales ratio, and if you squint at this a bit, this is just a weighted average, sales weighted average of the export sales ratio. Did it grow because conditional on exporting firms are exporting more of their sales? And then this last term at the end, this is the average size of an exporter relative to the average size of all the firms in the economy. Exporters are bigger than non-exporters. That's just a fact. Right? And so you've got these 3 terms here. Are more firms exporting, conditional on exporting? Are they selling more? And then how much bigger, right? How much bigger are these exporters versus non-exporters? So we want a model that kind of is going to capture a lot of this. Today, I'm just going to think about exports as just exports to anywhere in the world, right? A more careful version of this breaks things down by destination. It's in papers and things, you can look at it. But for now, just think about, I either sell something to this rest of the world or somewhere else. Okay, so here's what these data look like. For the United States, so you have to go and get permission to go sit in the census and go through this data. Or Colombia, whose data are much easier to get to. They both show kind of the same things, right? So start with the top line, export sales. So you can see in the United States, that's just about doubled from 1987 to 2007. The US now exports a bigger chunk of its output than it did, and even more so for Colombia. Right? This is globalization, right? This is the integration of markets and more firms and more sales happening outside the country. So the next 3 lines are those 3 terms that were on the right-hand side of that decomposition. The extensive margin. In the US, something like 43% of firms were selling something. It goes up to about 63% in 2007. So a lot more firms are now engaged in this. In Colombia, that number is about 36, goes up to about 60. Right? So we've got this increase in trade. Part of it is coming from that there are more exporters. The line that says intensive, right? Remember, that's just like this weighted average of exports to sales. That says each firm is now they were on average selling about 10% of their stuff abroad. Now they're selling about 15% of their stuff abroad, right? So in a model that's naturally going to happen as you lower trade barriers, firms are going to sell more of their stuff outside of the country. And yeah, go ahead.
That incentive, was that conditional on exporting?
Conditional on exporting. Yes, that's right. So that's conditional. So yeah, your average firm actually doesn't even sell that much abroad to the extent it does. There's a lot of heterogeneity. Apple makes something like, I don't know, 70% of their profits come from outside of the US, but on average, that number is fairly small. And then the last one, the premium, right? How big is an exporter relative to the average firm in the economy? That actually shrinks, right? That's getting smaller. And again, the models are going to naturally kind of give up this. What happens as we say lower tariffs, right? We make it easier to trade across countries. We're going to start sucking in countries that are firms that before weren't able to kind of hack it, right? And those are going to be kind of smaller, less productive, or less profitable firms in general. And so we get that the premium starts to shrink a bit. We're getting smaller firms now engaged in international trade, right? So that's kind of like that's how trade grows. And then, the opposite happens when trade barriers increase. At the bottom here, for some of the pieces of this data, I can compute the starter and stopper rates. So by starter rate, I mean number of firms who started exporting today divided by number of firms that were not exporting yesterday. So in Colombia, something like 7%, 7%, or goes up to 14%. This kind of, and then the stopper rate, number of firms who stop exporting today who exported yesterday. So there's significant churning, right? It's not like 10% of firms are sort of moving their way in and back out of markets. And it's that kind of churning that's going to kind of help us. We're going to try to match up, these types of numbers, right? So there's lots of stuff happening in export markets. I'm going to say one more thing about the intensive margin, then we're going to move on to look at models. This is the intensive margin. So conditional on exporting. What fraction of my sales do I export? And now I'm going to condition this further on how long have I been in the market, right? So for a new firm, a firm who just starts exporting, on average, they're exporting about 14% of their output. And then as conditional on staying in the market, if they've been in the market 7 years, that number just about doubles, right? So this is, the data are showing us, kind of a firm life cycle. A firm enters small, it kind of grows, conditional on staying in the market. What I'm not showing you is that the probability of leaving the market when you just start is very high. You might say, this sounds a lot like any other kind of firm. And I'd say that's exactly right? Just if you think about a brand new firm that's not doing exporting, you start a restaurant in Madison, Wisconsin. A lot of times you close early. You close early on. You stay open for a few months. It doesn't make it. You leave. Conditional on staying in the market, you kind of grow. We see the same kinds of dynamics here. And this is the same thing just as you're getting ready to exit. Right? So as you're getting ready to exit 7 periods prior, you're shrinking. Right? So this is the data are talking to us about firms who are entering, maybe they're exiting again, they're growing, they're shrinking, exactly the kind of firm dynamics that you might expect, right? So I want to build a model that can kind of explain this and lots and lots and lots of other features of the data that we don't have time to talk about today. This is kind of what should be in the back of your head, this kind of churning of firms and the births and deaths and growth, okay? So with that sort of bit of data in the back of our heads, let's think about some models to do this. And so here comes a model that you guys have already sort of seen and thought about, and this is in some sense a nice application of it. So I'm thinking about a firm who's making their decision to enter an export market. Right? I'm going to call that variable X. It's just 0 or 1. Do I export this period or not export this period? And here's like the sequence problem, right? So the profit I would earn from selling, so for firm I, the profit I would earn from selling in the market, and then some fixed costs that I might pay for being in that market. There's my 0, 1. I need to discount some stuff. I'm going to take the expected value of this, right? The value of my firm as an exporter is the potentially infinite sequence of profits where I may or may not be exporting in some period. I might enter the export market for a few periods, exit for a few periods, enter for a few periods, or I might stay in the whole time depending on what the shocks look like, right? This could be a very general problem. And so the the choice variable is this infinite sequence of export decisions. And we'll put some more structure on this in a minute. The fixed exporting costs can depend on lots of stuff. So there can be a stochastic component. You guys have seen a lot of this, right? I'm going to move jobs, or I'm going to move to a different part of the country. I've got some cost of moving something, and then I tack on some kind of extreme value, some clever extreme value error or something, right? We can do the same thing here. And we can also make this thing be history dependent, right? And in fact, the history dependence here is going to be important. We'll kind of trim it just to depend on one period's past for the model. But the idea here is that there's some history. Whether I'm exporting today kind of largely depends on whether I exported in the past. And then we can see some of that's going to come from this. Okay, so that's how fixed costs could look in the most general point. Profits depend on stuff like how good am I at producing stuff, some kind of TFP sort of measure or other things like that. Demand conditions, and then whether or not I'm exporting X. The way I've written this problem down, I'm assuming that there's constant returns to scale here. That helps a lot, right? Why does it help? Constant returns to scale says I can separate each market individually, right? So in our simple world where there's just the United States and the rest of the world, what I do in the rest of the world doesn't affect my marginal cost in the United States. That's probably not a perfect assumption, right? If I'm like really working hard and selling as much stuff as I can, I'm really producing a lot to sell the rest of the world, I could be raising my marginal cost at home, and so those two markets are tied together. Here, and an often assumption is that these things are constant returns, so I can split these two apart, right? So if not, we can include it, and just here now how good I am at producing stuff now depends on both what I sell abroad and what I sell at home. Right? And there's actually kind of interesting stuff to learn from that, to think about how those things you can look at domestic sales and export sales and kind of how they're correlated and learn something about that as well. But today I'm going to skip it and just say this is constant returns. It also keeps you from having to solve like some nasty combinatoric problem. Okay, so let's take a stand on some stuff. So we're thinking about just a partial equilibrium world right now. So let's just take a demand function, which later is going to be derived from an optimizing consumer who's also providing labor and investing in capital. But right now, let's just give ourselves a demand function. And then write down a constant elasticity of substitution demand function. That's the elasticity there. P, that's an aggregate price in the rest of the world, right? That's like the real exchange rate, depending on how you write how you write this down. And that's some kind of aggregate demand, the size of total demand. Right, so those things, again, are going to come out of the general equilibrium part later. For now, just think of them as being exogenous to the firm, and they just take them as given. There's the price the firm charges. I'm going to use tau to talk about like something like a tariff, right? And I'm going to use this xi to talk about some kind of trade costs. They show up kind of the same, right? They're multiplicative, but the thing you should be thinking about though is tau is like a policy. That's something a government can change. I can lower the tariff, I can raise the tariff, right? Xi is like a technology. The government can't all of a sudden make boats travel faster across the Pacific Ocean, or change how expensive it is to put something on an airplane, right? And so these x's can have both an aggregate piece, the price of oil makes shipping more expensive for everybody who has to ship something, and some idiosyncratic stuff. My good is light, my good is heavy, my good is perishable. It's going to kind of make it more or less expensive. And then I can have an idiosyncratic demand shifter too. From the data I have, I'm not going to be able to separate omega from the xi, so I'm going to roll them together and just have that one idiosyncratic kind of shifter there, okay? An interesting thing, particularly if you were alive 2 years ago or 3 years ago, congestion, right? Thinking about port congestion, what happened in 2001 and 2002. I'm going to abstract from it, but this is kind of interesting stuff people are thinking about now using models like this. All right, so that's kind of demand. Fixed costs, so now I'm going to start to make some assumptions on the fixed cost as well. I'm going to say only one period ago's export status matters. You can add more. The more you add, the harder your dynamic programming problem is, right? You're just blowing up your state space. Here, I only need to know, was I an exporter or not last period? If I need to know I was an exporter 2 periods ago, 3 periods ago, I'm just adding to my computational burden. This is going to come out of an estimation, but let's just get it out there now. The cost of entering is larger than the cost of continuing in the market. That's an important feature of these models, right? And then the difference between those two, the difference between the larger entry cost and the smaller continuation cost, that's the part that's sunk, right? So that's going to generate some interesting sort of dynamics that are going to help us match the data. But so you just think about there's like a bigger upfront cost. I've got to relabel my good into foreign languages. I have to figure out how to get through customs. Maybe I have to hire some lawyers or salespeople. That's the stuff I have to do when I first get started. For every year I stay in the market, I still have to make some investments, but they're smaller, okay? And then, just a way to think about it is if I haven't paid my fixed costs, you can think about my trade cost just goes to infinity, right? I can't ship anything if I don't do this. Okay. Uncertainty. I'm going to allow for today, just some simple forms of uncertainty. There's going to be uncertainty over my productivity, how good I can produce goods, uncertainty over my trade costs, how expensive it is to get my good from my country to the other country, and then I allow for some uncertainty on my fixed costs, right? A little bit of noise. So I got a fixed cost, and then in some periods my fixed costs are lower. Maybe I met somebody who lives in the rest of the world, and we've learned some stuff that's made it easier for me to export, something like that. And I'll let these guys just follow AR1 processes. Okay, and then the fixed cost will just be IID. Macroeconomic uncertainty, well, if I was going to write this down as a partial equilibrium model, which sometimes I do, depending on what kind of paper I'm writing, then I need to come up with some processes for my P and D, right? So a P is like the real exchange rate, so I can go and estimate some AR1 or AR2 off of the real exchange rate. I can do stuff like that. In general equilibrium, this stuff all comes through the general equilibrium, right? So I've got some structural shocks, but then aggregate prices and aggregate demand are just kind of part of the partial equilibrium, and that all kind of hangs together, and that's where that comes from. Interesting stuff people are thinking a lot about right now, uncertainty over tariffs. I don't know, what's Donald Trump going to do if he becomes president? What's Kamala Harris going to do if she becomes president? Do we undo tariffs on China? Was China expecting the trade war? Lots of sort of thoughts about how to deal with uncertainty over tariffs, but there's no kind of standard way to do it because it kind of depends a bit on what you're studying, right? So, but certainly uncertainty over tariffs is an interesting thing that people are thinking about now. Okay, so that's sort of enough structure to now write down like the Bellman equation, right? So remember, I'm a firm, I'm operating in the United States, and I'm thinking, do I want to export or not? And we looked at that like sequence problem. That's too hard to solve. But the recursive version is more straightforward. So here's the value of my firm. Here's my state variables as a firm, right? What did I do last period? Did I export or not export? What's my productivity? What's my variable trading cost? What fixed costs do I face today? And here's the discrete part, right? Here's the discrete choice. V0, I don't export. V1, I choose to export. We'll define these V's on the next slide, so hang on. A couple things we still need. I'm going to add in some just exogenous death. Sometimes the firm, you were the firm that was, you're producing a good and nobody wants your good anymore. You sort of go away. And then we need an interest rate. Again, the interest rate is going to come through general equilibrium in the end. I'm kind of being general here and writing T's on my value functions. These things don't have to be stationary. It can be that V is moving around. It's going to be the case when we look at some experiments in general equilibrium. Here's those two values. So this is the value if I don't export. So what happens? I earn some profits today. That's equal to 0, so I'm just earning profit from selling domestically. Maybe that's just 0. This is the probability my firm is still alive next period. I'm taking the expected value, discounting over what? This is the value of my firm tomorrow, where I'm starting off again as not being an exporter, and then these are the future values of my states. If I choose to export, I get profits from exporting today. I have to pay the cost, and then I start off tomorrow as an exporter, right? So that's kind of the discrete choice, and the big difference is because, remember, this F depends on what I was doing last period, right? So let me show you kind of how to think about this, right? So models like this, as long as profits are increasing in like productivity, so monopolistic competition, for example, gets you this. Perfect competition, whatever, something's going to get you that. Where it's, I'm going to use monopolistic competition. And then let me just say, let's let F be deterministic for now. Right? Like F is just a number. There's a fixed cost I pay. Then the optimal policy here is just a cutoff rule. So for each value of the trade cost, there's a Z such that I'm exporting if my Z is higher than this. Right? So I'm just like partitioning firms. If you're productive enough, you export. If you're not productive enough, you don't. And that equality, right, I just set V0 equal to V1, gives me something that looks like this, right? So what is this? On the left-hand side of this is the fixed cost I have to pay today to be an exporter, minus the extra profits I get today from being an exporter, right? So the left-hand side is like what I do today. I pay a cost today, and I get some extra profits today. And then this is what? This is the increase in the expected value of my firm from being in the market, being an exporter tomorrow, right? So what that says is this Z, the cutoff Z, is the one that exactly balances the cost of entering versus the expected future gains from starting tomorrow as an exporter. Right? That's this forward-looking decision. This depends on everything that's happening in the future. It's not. That's the dynamic kind of part. These firms are forward-looking firms. Here, let me just plot these. I'm going to plot this. These are the downward sloping lines. And this is the upward sloping line. And remember, there's two Fs. There's an entry cost F if I didn't export in the past, and there's a continuation cost F if I did export in the past. So that's why I have two downward sloping lines. And this is the upward sloping line. This is productivity. The more productive I am, the more I gain from being an exporter, right? That's this upward sloping curve. You want to export the more productive you are, the more stuff you can sell because you can charge a lower price, the better it is to be an exporter. And then again, same thing here, right? This is my fixed cost. I can earn more stuff today also if I'm more productive. So these things are downward sloping. And then for a particular level of the trade cost, I get these two cutoffs, right? So this is kind of what drives a lot of the interesting dynamics of this model. So think about what this says. Right? So remember, this is the threshold. If I've never exported and I want to enter the export market, I need to have a Z big enough to clear this threshold. I need a Z higher than this, right? But if I'm already exporting, if I'm just paying the smaller fixed cost, I'm already exporting, I just need a Z higher than this. And this area in between, right, this is the kind of band of inaction. If I've already exported in the past, I'm exporting today. But if I haven't exported in the past, I'm not exporting today, right? This is kind of history dependent. I can see two firms with the same level of technology in here, and it's just history dependent on whether I observe them being exporters today or not, right? So think about how this would work. I don't know, I'm a firm, I'm domestic, I get a high Z shock, I'm pretty profitable. It's enough to jump me here over into the exporting zone. Then I maybe get some mean reversion or I get some bad luck and my Z starts falling over time, right? Now I'm less productive than I was when I entered, but I don't exit. I don't exit until my Z falls all the way below here, right? And so that kind of drives what people talk about, say, hysteresis, that what's happened in the past is kind of determining kind of what happens today. So, okay, so it's harder to break into an export market than it is to stay in an export market. That was, export hysteresis we talked about. This is going to delay exit, right? Like you don't want to exit the market because you know that if you want to export again in the future, you're going to have to repay that larger entry cost to get back in. Right? So that kind of gets you to delay this. And then this gets you, amongst other things, this exporter premium that we talked about on the first slide of data, right? Exporters are bigger than non-exporters. Let's go back to this. In this model, higher Z means you hire more workers, you sell more stuff, you're a bigger firm. So here's my exporters, they're big. Here's my non-exporters, they're smaller. The further apart these two things get, the less that's true. Right? Now I've got, these two things are further apart. Now I'm mixing more of my exporters and non-exporters are kind of overlapping, right? That's kind of part of what's giving us identification later when I'm thinking about how do I find these fixed costs? Well, one of the things the fixed costs are going to give us, because the fixed costs are telling me how far apart these things are, is how big that exporter premium is, right? How much mixing is there versus just a pure separation. So that's coming. And so this model kind of gives us, and it gives us lots of other stuff too that we don't have time to talk about. But this is a pretty good model to start thinking about how to model the data that we see. Okay. All right. So now I've got a firm decision. I got a value function and some policy functions. Again, remember, I'm looking ahead to like what I need to do when I want to aggregate all this stuff up. So now I've got to think about the distribution of firms. So I'll call that mu. All right, so mu, so I've got a firm of type Z, C, and F. And I need to know, how many of those different types of firms are out there, how many of them are exporting and not exporting. Computationally, or at least when you're writing the code, keeping track of this is the most complicated thing. It's not the thing that makes the code take the longest to run, but it's the thing that takes the code longest to write. You're spending all this time doing like accounting, like bookkeeping, trying to get everybody in the right buckets all the time. Once I have those distributions, then I can kind of aggregate up. How many non-exporters do I have in my economy? Well, if I integrate over all the values of the trade costs, for each one of these trade costs, there's a threshold. Right? So these are all the firms who didn't export in the last period and whose productivities didn't cross the threshold for entry. These are all the firms who did export last period, but whose productivity fell below the cutoff value. And similar things here. These are all my exporters. These are my firms who didn't export last period, but whose productivity crosses above the threshold for entry. These are all my firms who exported last period and have stayed above the exit threshold. Right? So then from there, I can do stuff like define the export participation rate, for example.
Okay.
Yes?
All those F's you had before, those were fixed costs for different export markets, right?
Yeah, so I'm just going to have one export market today, but yes, you could have Fs for different markets. Those Fs could be correlated, right? Like if I'm already exporting to Germany, maybe now it's cheaper to export to France, for example. And you see stuff like that in the data, that firms tend to export like in clusters. Like you kind of like make a beachhead in Europe, and then you kind of start to kind of branch out from there. So you could do something like that. Not today, but that's a thing you can do. Yeah.
So as you're modeling all of this, for the sake of symmetry potentially, it's not so crazy to think that in the domestic market something similar is going on, that to break into the West Coast.
Absolutely.
We can also think about other ways of thinking about markets as being differentiated from each other. It's not just in sort of geographic space, but
For sure.
do you consider a dynamic model for, like, now my productivity is so high, now I can break into the West Coast as well, like that your dynamics in the domestic kind of follows a similar kind of process? You don't get to see all those different markets.
Yeah,
So there's a
yeah.
data problem.
Yeah.
But in terms of the dynamics, it sounds like standard models are trying to do Jabrat's law and other kinds of things.
Yeah.
Would that conform to a process like this where you just have a bunch of fixed costs and getting into
Yeah,
parts of the market?
Yeah, that's a good point. Maybe I should have made that point earlier too. I said there was no I/O here. This is kind of like I/O, right? Don't tell anybody. But this is very much, right? Like Harley Davidson deciding whether to sell the motorcycles in Mexico isn't that different than like Chipotle deciding whether to open a burrito restaurant in Madison, right? And like you said, there may be different. So in this model, markets can be different by their size. Like The US is a big market. Iceland is a small market, right? They can differ by how hard it is to get your good to that other market, right? So Iceland is far away, Canada is close. Iceland's not that far away. China's far away, Canada is close. They can differ by policy, right? So high tariffs on your good in one country, low tariffs on your good in another. It could be like sales taxes are higher in California than they are in the US. Maybe I don't want to, sell hamburgers there because that's not the right market. So yeah, this is, and so certainly, these models kind of in some sense come from people thinking about, this isn't some version like Hoppenheim's model, right? This is like Hoppenheim's model plus some extra decisions about exporting, right? So yeah, this has a lot of those same flavors and is going to give you a lot of those same ideas.
When you do it, do you
Yeah.
tend to think about the domestic side as following similar kinds of processes, or does the domestic side take a seat in what you're doing?
Usually usually in my own work, I'm abstracting from the US side, right? Not because it's not interesting, but because it just adds more complication. But you certainly could.
Find that informs or interacts.
You can. So when I have worked on stuff where I think about the domestic market as well, I tend to think of it as just like a country, not different parts of the country, but just again to keep things tractable. And then it's like what I was saying before. So for example, if you think there's decreasing returns to scale, now what I do in one country depends on, it influences the other country. And there's things you can learn by looking at, when I see a surge in exporting, do I see like a decrease in my domestic sales, right? Like, is there some trade-off, right? And so that is, and then it can also, try to help you, if you think about two foreign countries, again, it's like that, looking at my sales to Canada versus my sales to Australia, one country's close, one's far away, that can also help me learn things about the cost structures too. So if you're willing to make your life harder, you can add more heterogeneity and learn more stuff, absolutely. Okay, so there's some laws of motion for these firms, right? I'm gonna just write them down in a very kind of stylized way because others there's lots of integrals and it's complicated, right? But from every period to the next, there are firms growing, shrinking, becoming exporters, leaving exporting, staying as exporters, and so these distributions, have some kind of somewhat complicated laws of motion, but eventually, this model in like the steady state has like an invariant stationary distribution over this measure of firms, right? And so this model, without any kind of aggregate shocks, will eventually settle down into a stationary steady state where the aggregates are constant, but firms are constantly bouncing around, right, inside the distribution. Here's like what that would look like. So here's what these distributions sort of end up being. This is from an estimation of the model, kind of meant to match the data where there's not very many exporters. So here's the distribution of productivities for exporters, non-exporters, and all firms. And you see the export distribution is shifted to the right. Firms who export are more productive, or they're larger. But also there's this overlap, right, between the exporters' distribution and the non-exporters distribution. So here, there's some firms with the same value of Z, some of whom are exporting, some of whom are not. That's what that, having the difference between the entry cost and the continuation cost gets you. It gets you that mixing of firms. And so in the estimation, I'm going to try to, match firm size distributions in the data with firm size distributions in the model. Right? That's going to be part of the moments I want to match. Okay, so that's like the partial equilibrium model, right? I have the kind of discrete choice decision problem. Let me just show you sort of like, as thinking ahead to when we're doing it in the full-blown model, this is like how trade liberalization works in this model, right? So I'm going to lower a tariff. I'm going to permanently, now and forever, lower the tariff, right? So when I do that, two things happen. One, I earn more profits today. The tariff falls, I get to sell more stuff because my delivered price to the other country has fallen, and these guys are buying more stuff, right? And so that lowers the kind of adjusted cost of entering or staying in the market. Both of these lines shift down, right? That's the effect today. And then it also increases my value of being an exporter in the future, because now I get to earn more profits in the future because the tariff is lower in the future too. That shifts this curve up. And then what's that going to do? That's going to shift the break-even points off to the left. You're going to get more firms who enter. Right? So lowering a tariff does two things, right? It changes the extensive margin, how many firms choose to be exporters, and it changes the intensive margin. Conditional on being an exporter, you sell more stuff. Right? So then think back to that very first piece of data we looked at. Right? We saw as trade grew in the United States and in Colombia and other countries, both the number of firms that export goes up. That's what's happening here as these things shift down. And the amount of stuff people sell, conditional on selling, goes up. And that's going to be what happens here too. And then the third thing, remember, was that firms shrink. The average exporter relative to non-exporters shrinks, right? That premium gets smaller. Same thing's going to happen here, right? We're shifting the Z's down. The firms who are exporting now have lower productivities. They're a bit smaller. And so this model is kind of rationalizing kind of those three margins of growth there, of aggregate growth. Okay? When we go to the general equilibrium, we kind of work out the aggregate dynamics of this. This doesn't happen instantaneously, right? This is going to happen over time. Firms are going to kind of enter and grow, and this is going to take time for the change in tariffs to kind of work its way through the economy. And I'll show you some of that. Okay. General equilibrium. So now I'm going to take that model we just talked about, right, and just put that into a two-country dynamic general equilibrium model. Right? So everything today is just going to be with symmetric countries. That's fine. It's kind of straightforward to make things be asymmetric, and you get more kind of interesting stuff. But this is just to keep things simple. So in that case, since everything's symmetric, trade is always balanced, right? Just as an aside, what are we not going to get out of this? Right, so I lower tariffs, the other country lowers tariffs, we trade more, but we trade more in a balanced way. With asymmetric countries or asymmetric tariffs and tariff policy, you're going to end up with like unbalanced trade and then capital flows, right? So this is a model that you can use to think about the effects on capital flows as well. I'm going to abstract from that today, but it's pretty interesting stuff. It's in some of the papers that are on the GitHub. Besides just that, we're going to have physical capital, intermediate goods, and then free entry. So I hadn't talked about free entry, but free entry exactly in the way like Oppenheim would do it. So there's a potentially unbounded mass of potential firms. They have to pay a cost to create a new firm. And then once that firm's created, it's making that decision to export or not export. Right? So free entry there. So general equilibrium, just a quick minute on why general equilibrium. This is going to make my life a lot harder, right? Once we have to go through and solve those dynamic discrete choice problems inside of then the larger general equilibrium kind of framework. The usual thing, right? We want to think about feedbacks. If I'm thinking about a big policy, like the US raising tariffs on China and maybe raising tariffs on the rest of the world, these are like big policies. We might think about how this is kind of feeding back through, right? Also, these feedbacks are typically going to dampen the effects of things. So in partial equilibrium, the effects are going to look bigger. General equilibrium is going to look smaller. And then also just, general equilibrium gives us this sort of discipline that partial equilibrium kind of doesn't, right? I got to get prices and quantities right. And that's just kind of tying my hands, in interesting kind of useful ways. Okay, so let me just show you just some of the elements to get us into into the model, and then talk a bit about how to actually try to solve this thing. So I'm going to let my differentiated good firms. Those are the firms who's making these dynamic discrete choice problems. Right? So now I put some market structure on these firms. So these firms are selling differentiated products, monopolistic competition. So this is like. Ariel's not here right now. This is like 1990s I/O, right? So this is. But you need to make some simplifications. That's probably the biggest one. And people have moved away from monopolistic competition into things where markups are non-constant and stuff. But nobody in this kind of literature is doing like dynamic games. It's just too hard, right? Not because it's not interesting. People, maybe you guys will figure it out. You're young and you've got time. production function, use capital and labor, and then some intermediates. Why bother with intermediates? Want to get the model, again, we're thinking about like an aggregate model of the US economy, and the US economy value added and gross output are not the same thing, right? It's like gross output's like 2.8 times bigger than value added. And trade is measured as gross output. We don't have measures of like the value added of a Harley Davidson as it crosses the border. We just know the value of that Harley Davidson. So we got to get the model to line up with the data, we need to have a concept of gross output being different than value added. And so, we have some intermediate goods, and that's okay. That's not going to cost us much. Right? So those are the goods that go into using that. I'll let Z follow an AR1 process. So firms are kind of bouncing around. Okay, so I've got all these firms, all these little firms making these dynamic decisions about exporting or not exporting, how much capital to rent, how much labor to hire. All of those little goods are going to get aggregated into a kind of final good, right? So again, think about how do you build these models? What are the kinds of decisions you have to make? Well, one decision you have to make is how to aggregate stuff. Right? Like, what are all these little firms going to do? How is capital made? What are we consuming? So this is how we're going to aggregate this stuff, right? So these are all the varieties where S, remember, is just the state of these different firms. All the varieties of, this is for the home country, all the ones made in the home country. There's those distributions and how many of them there are. And then these are the imports. These are the ones made in the foreign country, right? With the understanding that in the foreign country, imports, right? This depends, I can't consume a good from the rest of the world unless there's an exporter on the other side who's paid the fixed cost to be able to ship the stuff to me. So there's going to be varieties produced in the foreign country that I don't have access to, right? There's someone in Mexico right now is making a beer that I really would like to drink, but if that Mexican firm hasn't paid the cost and entered the US market, I don't get to drink it, right? So that measure of firms there, that's not the entire set of firms in the foreign country, it's the set of firms that are exporting to my country. Okay, so I aggregate that stuff up, and then that's sort of how we form consumption and investment, right? And in the intermediate goods, right? So I'm my firm, I hire some capital, some labor, and I get a lump of this, this aggregate of goods, and that goes into my production. Here again, you can make some different choices. You could have the mixture of imports and domestic goods be different for consumption than it is for capital. In the data, that's true. Most imports go into either intermediate goods or capital goods. We don't import directly a lot of consumption goods. Okay, so again, for simplicity, these are all made up of the same good, but they don't have to, right? You can make different assumptions here. The household, so the household's pretty not interesting in this model. They consume, they invest in capital. They're the owners of the firms, so they own all of the firms and get the profits from them. That's tariff rebate, that's tariff revenues lump sum rebated back. But otherwise, nothing super interesting here. I've abstracted from like an endogenous labor choice. Again, especially when we start thinking about like asymmetric countries and real exchange rate, you want to start thinking about stuff like that. Having a labor decision is probably interesting, to add back in. The intertemporal elasticity of substitution, actually for these kind of like when you're thinking about the dynamic aspects of these models, does matter. How much do I care about the future? How much do I want to substitute between now and then as I'm making changes? Okay, so that's the model, right? So there's a bunch of market clearing conditions I didn't write down, but so I'm going to talk now about kind of estimation and computation. So let's think a little bit about this is like a nested fixed point problem, right? So the outermost nest parameters, like the estimation. So think about for a given set of parameters, now I have to solve the general equilibrium problem. That's a fixed point problem. And then inside that general equilibrium problem, I have to solve those value functions. That's another fixed point problem, right? So it's like three, stylistically at least, it's like you can mix stuff up and so it's not so bad, but stylistically it's like there's three fixed points to do here. So, so let me walk you through some of this stuff. So again, thinking about what am I thinking when I'm writing these papers, or how am I making decisions about stuff? Different literatures have different ways they do stuff, and you should write to the literature that you're trying to convince to hire you or publish your paper. So the strategy here is I'm going to think about the country as being the United States and then a symmetric rest of the world. And think about this being the United States in the early 1990s, kind of before the big trade liberalizations of NAFTA, China joining the WTO, things like that. And I'm going to assume the United States is in a stationary equilibrium in the early 1990s. Right? That's an assumption. It's probably not true, but that's how we're going to start the model. So now I've got a bunch of parameters of this model. I'm going to break them up into two sets. One set that I can choose or estimate without having to solve the whole equilibrium. Either I can get it off of an equilibrium condition, or it's just something I can read right out of the model. And then ones that require kind of solving the whole equilibrium and then doing some kind of I say SMM. I remember Dean was saying, I don't know which one he says, but some simulated method of moments part, right? So part 2 is the hard part. Okay, so here's the easy part. So there's two parameters I'm not going to estimate at all. The elasticity of substitution and the intertemporal elasticity. With the way the model's written down and the data that I have, the intertemporal elasticity is not really very well identified. Theta, the elasticity turns out is something more like it's not a normalization, but it's not easy to actually back out theta. So I'm going to leave those for today. These are the ones that are just very easy to read off of as equilibrium conditions. A tariff rate, a real interest rate, capital depreciation, income share, those are pretty standard. Here's that thing I was mentioning before, gross output versus value added, right? In the US economy, that ratio is like almost 3. And so that pins down how important intermediate goods are in production. Okay, the harder part, the part that you guys came here to listen to experts talk about how to do this. Now I'm just going to show you how I do it. I'm not an expert. So I'm going to make an AR1 process for Z. Remember, that's productivity. And an AR1 process for the CACs, which are the trade costs, the variable trade costs, right? I'm going to discretize Z into a bunch of different values, several hundred. And then for this, I don't need very many Cs. Yeah, so let's just have 2 for today. There's a high cost and a low cost. If I have the high cost, I'm a bad exporter. It's expensive to ship stuff to the rest of the world. So my export sales ratio is going to be low. I don't ship a lot of stuff because it's expensive to do so. When I have the low cost, I'm a good exporter, and I can ship more stuff. So I doubt you guys have been carefully keeping track, but I have at some point. Here's all the parameters we need to estimate. These are the parameters for the trade costs. These are those 2 fixed costs. These are the parameters that govern TFP. These other 3 I haven't talked about, but let me just point it out. Mu E, that's when I create a new firm, not a new exporter, but a new firm. I pay some cost to build a new firm. I'm going to draw from a distribution that's kind of left shifted from the ergodic distribution of productivity, because firms are small when they begin. So that's a parameter to do that. And these are 2 parameters that are related to the exit process, that firms kind of exogenously die. Okay, so there's a bunch of moments that have to be estimated. Or, I'm sorry, a bunch of parameters that have to be estimated. So to do so, I have to be able to solve the model. So let me talk about solving the model. So let's assume I have a set of parameter values. I do the normal thing, or the usual thing. You've got to set stuff up. So construct some grids over Z and over Xc. Use your favorite kind of approximation to turn those AR1 processes into discrete Markov chains. So you kind of do that once, set the problem up. Now here comes this kind of double fixed point problem. So first, you got to guess some aggregates, right? This is the general equilibrium part. So how much capital, how much consumption, and how many entrants do you have? So given those guesses, I can solve the value function just using probably high-tech things you guys are learning about here that I didn't learn about as a student. Just imagine even just value function iteration. I'm just going to solve these value functions and get some policy functions. Then I'm going to compute the stationary distribution implied by these value functions. Excuse me. And I can do that just by iterating on the laws of motion that I get from these decision rules, right? So I solve the value functions. I now have the stationary distribution over firm types. And then I use that stationary distribution to construct aggregates. Now I know how many firms there are, so I know how much output there is. So I know how much then consumption, I know how much investment firms are making, right? So I can construct the aggregates. Then I check to see if I've got the general equilibrium right. Do capital markets clear? Does the free entry condition hold? Is the budget constraint respected? If that's true, I'm done, right? Now I have that double fixed point. I've got my guesses of K, C, and M are right, and all the value functions have converged, and I've got some prices, and everything's done. Of course, typically that's not true, and so I cycle back up to point one, right? So, I write something like this down computationally. I want to write something like this down as like a system of nonlinear equations, right? For example, I've got 3 unknowns and 3 equations, right? So I just kind of wrap steps 1. I kind of wrap these steps all up into one big function that takes K, C, and M as an input and returns, the error in these 3, and then I chuck the whole thing into a nonlinear equation solver, cross my fingers, and wait for this thing to converge, right? That's what it takes to solve for the stationary equilibrium. I'm going to talk about transition paths in a minute, but this is how you'd get to the equilibrium. So what can go wrong? Because we're solving like these dynamic discrete choice problems inside of this general equilibrium loop, one of the things that can happen is just if you don't have enough if you don't have a fine enough discretization of the state space, then what will often happen is these entry cutoffs kind of fall in between the nodes, right? So like I've got a state space point, I've got a grid that at a point at 1 and a point at 2, but the cutoff is like 1.3, right? And so you can then, that Z is going to bounce around, and what that can do is that can just kind of make things unstable, right? So I change the parameters a tiny bit, or I change my guess of aggregate capital stock a tiny bit, and then the model moves in some non-continuous way and kind of throws everything out of whack, right? So there's a lot of different ways to fix this. You can add some more noise, right? You can add some shocks in places to smooth stuff out. You can add more state space points. That starts getting you into cursor dimensionality kind of stuff. Or you can do stuff like you can kind of interpolate these things, right? So I know I'm at 1.3, so then I'm going to take basically a third of the people and put them on point 1, and 0.3 onto the point 1 and 0.7 and give those guys onto point 2, right? Just kind of, so you're assuming there's like people uniformly distributed between the points, and you're just breaking them up. But one way or another, these are the kinds of things that can often go wrong that talking to people who are good at computation can kind of help you sort out. So assuming you fix all that, then you're in good shape. So now we know how to compute a stationary equilibrium, right? So all the aggregates, capital, consumption, prices, and things are all constant, but I've got this distribution over firms, and firms are moving around in the distribution, right? But in a way where everything's okay, so then I got to figure out how to estimate this thing. So let's assume we know a vector of moments from the data. We'll come back to think about where those come from, but let's assume we have one. Then this is just, your typical simulated method of moments, right? You take a parameter, you take a guess of the parameters, solve the steady state, simulate a panel of data, compute the moments, minimize this thing, right? Same idea. I like to write this thing all into a function and then pass it to some sort of minimizer, or if you have an exactly identified system, even just a nonlinear equation solver, that's nice. But a lot of things I talk with students about, sometimes this takes me like weeks. You spend all this time writing the code runs, and you're like, yeah, I'm on it, I'm done, I'm almost there. and then you spend like 3 weeks just trying to get into the right part of the parameter space so that things aren't blowing up on you. But hopefully, once you end up with a good guess of gamma, and you can do grids, you can do different stuff to try to come up with a good guess. The better you do, the easier your life is. Right? So I'm gonna do that. That's fine. Okay, so I just kind of gave you like the stylized versions of these algorithms, right? That's like the kind of brute force way to do it. But there's lots of things you can do to improve these kinds of algorithms, right? So if you're familiar with Hoppenheim's model, right, the simplest versions of like Hoppenheim's model, you can solve, once you have the stationary distribution of firms, then you can solve for like the aggregate, you can solve for the price in order to make the free entry condition hold. And then you can solve for the aggregates to make all the market clearing conditions hold. You can do something similar here. It's just like a more complicated version of Hoppenheim's model. So you can break this stuff up a bit. You can solve for the value functions and the stationary distributions kind of first, and then solve for the entry and aggregate quantities, right? And so that just means instead of solving like, it kind of, in some sense, it breaks up one of the nests. So it makes your life a bit simpler. And then you can even do some of the estimation this way too. So you can break some of this stuff up into ways that are going to allow you to not have to try to solve everything simultaneously all the time. It's usually easier to solve a few smaller problems than one big problem. There's some decreasing returns to size. Computing moments. So I'm of two minds on this, right? So you've got your model, you've solved it. Now you need to compute the moments that you're going to compare to the moments from the data. One version is literally simulating panels. I like doing this because my data are typically finite samples, so I can finitely sample my model. And then the thing I really like about it is I have my sample of data, or I have my sample of model data. I can use the exact same code that I wrote to compute the moments from the data on the data that came from my model, right? So I'm not writing code twice. I'm not making mistakes because, I divided by 1 over n here, but 1 over n minus 1 here. Like you can literally just kind of reuse your code, and that's kind of nice. But it can be slow, right? Simulating stuff is slow. You throw away a lot of the stuff you simulated. The second version is just to kind of work out using the decision rules in the ergodic distributions, just work out all the moments literally from the model itself, right? So this tends to be very fast once you've written it down the right way, but you don't have this kind of small sample size. Right now you're getting exactly what the model moments are. I don't know, different ways to do it. I tend to do this. Okay, so I said earlier, you're going to compute some moments from the data. What moments, right? This is, again, one of these hard things that no one really told me about. How do you know what moments to choose? So those are my parameters, again, that I've got to sort out, right? So I need some moments, and not just any moment, right? What moments do I want? Well, I need moments that are informative about the parameters that I'm trying to estimate, right? How do you come up with moments? Well, sometimes I just sit in front of the computer and I change a parameter and see what happens. I said this is slow. This is the hard part. Think about computing like once you have some sense of some moments you might think are true, like compute like the Jacobian of your model with respect to the parameter space, right? You got a matrix now that's telling you how sensitive are different moments to different parameters. In models like this, there's no one-to-one mapping of moments and parameters. Everything's kind of changing everything, but you're hoping to find some moments that kind of move a lot or move in different directions as you move a parameter around to help you kind of sort it out. So after studying these kinds of models for a long time now, these are the types of moments that are helpful, right? So think about those fixed costs, the cost of entering an export market and staying in an export market. Well, those things determine stuff like how many firms export. Right? If I set F0 super high, no firm exports at all. If I set F0 to 0, every firm exports. So kind of somewhere in between, I'm going to start to get to stuff like the export participation rate. The stopper rate depends on lots of stuff, but also on how big the continuation cost is. And then we talked earlier about the exporter premium, right? how the difference between F0 and F1 determine, or one of the things that determine how big firms are. Right? Costs of shipping goods, that's largely determining the intensive margin. How much stuff do I sell abroad? Right? The more expensive it is to ship things abroad, the less I'm going to do. The more persistent those shocks are, the longer I'm going to stay in or exit the export market. So these are kind of telling me things about the export sales ratios. The moments from the productivity distribution, I often will do like some kind of indirect inference here. So I've got in the data, I can see sales for firms. So I run like just some, I run maybe a regression of sales today on sales yesterday, plus some fixed effects and maybe some other covariates, right? And then I can run those same regressions in my model data, and I just want to match coefficients from those regressions, right? That's that kind of indirect inference approach. Since my shocks are AR, my distribution of firms in the stationary steady state is going to be roughly log normal, and it's going to depend on these parameters, right? It's like what? Sigma z divided by square root of 1 minus rho squared or something like that. So this is also telling me stuff about the firm size distribution. Again, with firm size distribution, there's lots of moments from that I could match, right? I could match first moments, second moments. I can try to like fit a curve through it. So moments from the firm size distribution can be helpful. And then these kinds of things here are telling me stuff about how firms look, like how big they are when they enter, how big they are when they shut down, when they fail. Those are things that are all informative, kind of about parameters like this, right? So, I'm experimenting with the model, I'm trying stuff, and I'm coming up with a set of moments that's informative about my parameters, and then I'm kind of estimating everything. Right? And this can be frustrating, right? This can take time, but that's just sort of part of what we're signing up for. So now let me show you some estimates and then use the model to do something interesting. We kind of did all this work. What is it? What do we get out of it? So here's just a subset of the parameter estimates, the ones I find they're kind of interesting and novel and stuff to kind of sort out, and that tell us something about what's going on in the data. Right? So I'm going to normalize this so we get some sense of what these numbers sort of mean. Right? So remember, this is the cost of becoming an exporter. This is the cost of creating a brand new firm. Right? So it's relatively cheap to become an exporter compared to creating a firm. That sounds about right to me. Harley-Davidson has an enormous capital investment it took to build their factories and things. The cost that it takes to kind of set up operations abroad is sort of relatively small. The continuation cost is only about 70% of the entry cost, right? So like 30% of that entry cost is the sunk part, right? That's giving us that band of inaction between the two. It's kind of crummy to be a bad exporter, and it's pretty good to be a good exporter. If I had more X's, I get more variation in these things. And then my types are persistent, right? So if I'm a good exporter, I'm probably going to stay a good exporter. Not always. There's a chance I could become a bad exporter. But being a good exporter, you tend to stay one. Being a bad exporter, you tend to stay one. Right? So, okay. Those are just some parameters. But now I thought we'd try to do something with this. Right? So I wanted to show you what the payoff is from incorporating all these kind of nonlinear and complicated dynamics into like an aggregate general equilibrium problem. So I'm going to do it by considering a tariff liberalization. Right? So the U.S. signs NAFTA, let's say, and we lower tariffs. So I want to do this so you can, I've got the 1990 stationary equilibrium that I calibrated to, and I'm going to end up at another stationary distribution when the transition is done. I can compute those two things. I know how to do that, right? I've already computed the stationary equilibrium because that's how I calibrated the model or estimated the model. Sorry, I said the C word. And then the new equilibrium is easy too. I just change the tariff and just recompute it. I don't have to estimate anything, right? So now I have two equilibria. I have two stationary equilibria. but I want the transition path between the two. And that's another hard thing to have to do. So here was some assumptions I'm going to make. The tariff cut comes as a surprise. Doesn't have to, but it's going to make my life easy. So firms wake up in the morning and they see that tariffs have fallen to zero, and they're going to stay zero for forever. And I'm going to let my firms, or all the agents in my model, have perfect foresight. So that means they know what the transition path is between these two stationary steady states. How do I do that? How do I actually compute this thing, right? So I'm going to assume that I get to the new steady state in capital T periods. Maybe that's like 100. It was like 100 periods, I'm going to say. Okay. Guess some stuff. Guess a path of capital. That should be capital, comma, prices. Guess, so if I say it's going to take 50 periods, guess 50 numbers for the capital stock, starting from the first stationary state, going to the second stationary state. And the same for some prices. Right? So I'm guessing a path. Then given that set of prices and capital stocks, at every point in time, I can go through and solve those value functions. Remember when I said the value functions can be non-stationary, have a t on it? This is now. That's now, right? That value function is different at each one of those 50 points. You do this by iterating backwards. I know what the value functions are in the new steady state, right? So then I just roll that thing back. So that's at like time t. At time t minus 1, I know what tomorrow's value function is, so I can compute today's value function. At time t minus 2, now I know what t minus 1's value function is, so now I can compute t minus 2. And I do that all the way back to t0, my original steady state, right? So I've gone backwards and sorted out all the value functions. Now I iterate forwards. I have all the decision rules from solving the value functions. Now I iterate forward on the distributions, right? And so now I have a guess for all the distributions going to the steady state, and I check to see if my market's clear at each one of those points. They won't, not on your first guess, and so then you're going to change that sequence of capital stocks and that sequence of prices. You're going to keep changing those, iterating backwards on the value functions, iterating forwards on the distributions, until that thing converges, until you've got a sequence of prices and capital stocks that are consistent with all the value functions and the law of motion of the distribution, right? This is mostly bookkeeping. The solving for the distributions and things is mostly bookkeeping, but it does take a bit of work. Yeah, Fedor.
Would it be equivalent to clear the markets as you go backwards in this backwards connection?
So that could be how you come up with your next guess of the, say, prices. Let's make it simple. Suppose there's just one price we're trying to guess. As you're moving backwards, you can be computing like the price that would clear those markets, right? And then it's like a fixed point in prices. The prices I guessed, match the prices I come up with. That's right. Yeah. So, there's different ways to structure the problem. Something like that is what you need, right? So, but basically the big idea is I'm guessing the path, and then going back and confirming that that's the right path, right? And so then what that gets you is your two steady states and a transition path between the two. Right? And so that's good. Okay, so let me show you then what that looks like. Yeah, I have 5 minutes, 4 minutes, perfect. So I'm going to show you two models. The model we just talked about with all the firm dynamics and all the interesting pieces in it, and a model where firms are static. There's no entry costs, so everybody exports. There's no changes in CAC, so everybody, there's no intensive margin dynamics, kind of nothing. There's just basically firms are static and they're just exporting stuff. Here's how the two models look. So again, that trade liberalization, two steady states. So this left-hand panel here is consumption in the two models. So start with the static model. The static model, this is consumption. It kind of jumps up on impact, and then kind of slowly, in a kind of neoclassical looking way, converges what will eventually be its long run level, which is, further out than 25, but I stuck them here so that you can sort of see where it's going. It's already more or less converged by period 25, right? That looks like neoclassical dynamics because that's all it is. That's just capital accumulation. You lower tariffs, the economy is more efficient, you want to have more capital, and so this is just consumption smoothing as you build your capital stock up. In the model with dynamics, you get this kind of overshooting, right? You get like a hump shape to consumption. So you get a lot more consumption and less. And I'll come back to where this comes from in a minute. But you see these are kind of dramatically different sort of looking things. And then here's the expenditure share on domestic goods. So this is like 1 minus the amount of trading, right? So in the static model, this immediately jumps down and is flat. And in the dynamic model, it takes time to kind of move. Right? This is falling because we're now buying more stuff from the rest of the world. We're importing more stuff, so we're spending less money on our own goods, right? And you're getting this kind of gradual dynamics here. This is sort of easier to understand than the consumption. This is exactly the kind of adjustment that has to happen at the micro level, right? So as we lower tariffs, some firms are entering the market. Some of them are getting good draws and growing and becoming successful exporters. Some are exiting, and it takes time to kind of settle back into the distribution. And here you can, you're basically reading off, right, the time it's taking these firms to sort of adjust to the change in tariffs. Here's the number of exporters, the extensive margin. In the static model, nothing happens because everybody's already exporting. Nothing changes here. Here you can see, right, this is the slow accumulation of exporters. It's like tariffs fall. So now that tariffs are lower, more people want to enter. So tariffs fall, we dump a bunch of firms in the market. Some of them stay, some of them exit. Then we dump some more firms in the market. Some stay, some exit. More firms enter, right? And it takes time over these successive kind of waves of entry to get to the new steady state kind of number of firms. This is total number of. This is the number of total firms in the economy, not just the ones that are exporting. Right? These are the ones who are exporting. This is total amount exporters and domestic ones. This is where the hump shape comes from, and this is kind of. So look what's happening here. The number of firms in the economy is shrinking. What's happening? When I have a tariff, a bunch of those firms in the foreign country aren't selling their goods to me. So I like varieties, I like having stuff, so I build more firms in my domestic economy to sell me stuff. Well, once tariffs come down, I'm able to import more goods from abroad, and because of selection, those are cheap goods, right? I'm buying from the most efficient firms, so those goods are on average less expensive than the goods I'm producing in my own country, and so I just stop building so many of my own firms. Right? This is a model that says when you open to free trade, you should have fewer domestic firms. Right? The good firms should grow. The good firms become bigger and export more stuff. But the kind of small, not very good firms go away. Right? This is like the selection you get from here. And that's what this is saying. And so now you can see sort of where the consumption overshooting comes from. This is me getting to eat all that stuff I was using for investment as I'm letting like those firms kind of die off. And then eventually, I'll go to the new steady state, right? So that's sort of an important dynamic that comes out of this is that you should expect to see kind of consolidation of firms and kind of firms getting bigger when it happens. Okay, that's basically what I just said, so we can kind of stare at that. Last thing before we break is just how does this show up in like in the aggregates? I think the one that's sort of worth pointing out though is just the change in steady state trade is quite different between these two models. Here, the change in steady state consumption is big. Here, the change in steady state consumption is small. But welfare is much bigger in the dynamic model than the static model because of the overshooting of consumption. And so this kind of says that looking at steady states of a static model is not a good approximation for doing the work of writing down a dynamic model and solving through for the transitions, right? This kind of sufficient statistics approach isn't a good approximation. So maybe doing all that work was worth it. So, okay, I think I'm out of time. Thanks for coming, and I'll stick around to chat with you.